All right, these notes are for the after quiz notes, aka once you're done with the quiz, watch this video or look over the sheet. Like I said, you are turning in the sheets. I'm only doing maybe 1A and 2A so that you could do the rest on your own. But as a reminder from Unit 1 and Math 3, we want to look at the end behavior of horizontal asymptotes. You could see that if I have P of x in the numerator and Q of x being the denominator, if P of x is greater than Q of x, we don't have a horizontal asymptote. Instead, we might have a slant asymptote. And we'll talk about what that is next week. If P of x is equal to Q of x, you want to look at leading coefficients and divide them, and that's going to give us the horizontal asymptote. And if P of x is less than Q of x, then this tells us that our horizontal asymptote is at y is equal to 0. Those are going to tell us the end behavior as x approaches negative infinity and x approaches positive infinity. Now, looking at my vertical asymptotes, this is going to be where I look at my end behavior coming from the left side of my vertical asymptote and my right side of the vertical asymptote. So notice how here in this example right here, I have a horizontal asymptote at 1. So this tells me that as the limit of x approaches negative infinity, f of x will approach 1. So going from the left side. Likewise, as f of x approaches positive infinity, what happens there? It approaches 1 too. So that's my end behavior of the horizontal asymptote. Now, whenever we are looking at my vertical asymptotes, I'm going to have 2 limits, just like a horizontal asymptote. But instead of positive infinity and negative infinity, I'm going to look at my limit of my vertical asymptote to the left side and to my right side. So looking at this, I could say that as the limit of x approaches negative 4 to the left, notice how this negative right here represents to the left. This means that f of x approaches positive infinity. So this is my left side of the vertical asymptote. Here, this says as my limit of x approaches negative 4 to the right, which is indicated by this plus sign right here, to the right of my vertical asymptote, I could see that f of x will approach negative infinity. So that's what I want you guys to write on your tests, making sure that you put this in proper limit notation, or else I'm going to take points off like I did on the Unit 1 test. So make sure that your limits are pretty and I can read it nice. All right. Now, sometimes you might not be given a graph. You might be given, oh, look, an equation. We have f of x is equal to x minus 3 over x squared minus 5x plus 6. And I already gave you a couple of stuff. I already gave you that the denominator is x minus 3, x minus 2. And then the x minus 3's will simplify out to be 1 over x minus 2. This tells us that my horizontal asymptote is at y is equal to 0 because your denominator has a higher exponent. This tells us that my end behavior is going to be approaching 0. So as the limit of x approaches negative infinity, f of x is going to be 0. And then as the limit of x approaches positive infinity, that's also going to approach 0. Now, 1 over x minus 2 is just a horizontal shift 2 units to the right. So it should look something like, ooh, that is nasty. I'm sorry. Like that. And right here, this is like Math 2 stuff where we're just doing basic transformations. So it's just rank 2 units. You could also see your horizontal asymptote is at y is equal to 0. Your vertical asymptote is at 2. If you do not know the graph and how it looks like, then I would encourage you to substitute in the table of values that I have right here. Now, if you do know how the graph looks like, then this is going to be easy for you because you could just tell what my limit is as x approaches 2 to the left and as x approaches 2 to the right. Looking at this graph, this tells me that the limit of x as it approaches 2 to the left is going to be negative infinity. And then 2 to the right, I'm approaching positive infinity. And then right here is just a table of values so that you could plot them to see what works and what doesn't work. Now, you might have to do that on these examples right here because these aren't really your basic rational functions. So for these, you might want to substitute in some points. And as a reminder, the test will be calculator inactive, so you're not going to get a calculator, so you need to know how to visualize this by plotting a couple of points.